Have you ever stopped to think about that giant, glowing ball in the sky? The sun. It's so familiar, so constant, that we often take it for granted. But what if I told you that this celestial body is far more complex, dynamic, and downright incredible than you ever imagined? Today, we're going on a journey to the heart of our solar system to uncover the secrets of the sun. Let's start with the basics. The sun is a star, just one of billions in our Milky Way galaxy. But for us, it's the most important star of all. It's a nearly perfect sphere of hot plasma with a diameter about 109 times that of Earth. To put that into perspective, you could fit about 1.3 million Earths inside the sun. That's mind-bogglingly huge. And it's incredibly massive, accounting for a staggering 99.86% of the total mass of our entire solar system. Everything else, saw the planets, moons, asteroids, and comets, just leftover cosmic dust in comparison. So, what makes the sun shine so brightly? The answer lies deep within its core. The sun's core is an unimaginable furnace. The temperature there reaches about 15 million degrees Celsius, and the pressure is immense. In this extreme environment, a process called nuclear fusion takes place. Hydrogen atoms are smashed together with such force that they fuse to form helium. This process releases a colossal amount of energy, which radiates outward from the core. This energy is the source of the sun's light and heat, the very energy that sustains life on Earth. This journey of energy from the core to the surface is a long one. A single photon of light, a particle of light, can take hundreds of thousands of years to travel from the core through the dense radiative zone to the convective zone, and finally to the surface. It's like a pinball machine of epic proportions, with the photon constantly bouncing off atoms. But once it reaches the surface, known as the photosphere, it takes only about 8 minutes and 20 seconds to travel the 150 million kilometers to Earth. So, the sunlight warming your face right now actually began its journey from the sun's core long before human civilization even existed. The photosphere is what we see when we look at the sun with proper eye protection. Of course, it's not a solid surface like a planet's. Instead, it's a roiling, bubbling layer of gas about 500 kilometers thick. It has a granulated appearance, like boiling water, caused by convection cells of hot plasma rising and cooler plasma sinking. These granules are each about the size of Texas. Above the photosphere is the sun's atmosphere, which is composed of two main layers, the chromosphere and the corona. The chromosphere is a reddish layer, visible during a total solar eclipse. It's a place of dynamic activity, where you can see giant arches of gas called prominences and explosive events called solar flares. Solar flares are sudden, intense bursts of radiation. A single large flare can release the energy equivalent of millions of hydrogen bombs exploding at once. Even further out is the corona, the sun's wispy outer atmosphere. What is fascinating and still a bit of a mystery to scientists is that the corona is incredibly hot, reaching temperatures of millions of degrees Celsius, much, much hotter than the surface below it. It's like moving away from a fire and feeling it gets hotter. Scientists are still working to understand the exact mechanisms that heat the corona to such extreme temperatures. During a total solar eclipse, the corona becomes visible as a beautiful, ethereal halo around the darkened moon. It's a truly breathtaking sight. The sun is anything but static. It's a dynamic, active star with its own cycle of activity. This is known as the solar cycle, which lasts about 11 years. During this cycle, the sun's magnetic field gets all twisted up and complex. This magnetic activity is what drives many of the features we see, like sunspots, solar flares, and coronal mass ejections. Sunspots are temporary dark spots on the sun's surface. They appear dark because they are cooler than the surrounding areas, though they are still incredibly hot by earthly standards. These spots are areas of intense magnetic activity. The number of sunspots visible on the sun varies throughout the 11-year cycle. When the number of sunspots is high, we are at what's called the solar maximum, a period of increased solar activity. When the number is low, we're at the solar minimum. During solar maximum, we see more solar flares and something even more powerful, coronal mass ejections, or CMEs. A CME is a massive eruption of plasma and magnetic field from the sun's corona. Billions of tons of material can be launched into space at speeds of millions of kilometers per hour. When these charged particles from ACME or a solar flare travel towards Earth, they interact with our planet's magnetic field. This interaction is what creates the beautiful aurora borealis and aurora australis, the northern and southern lights. It's a spectacular light show powered by the sun. However, strong solar storms can also have negative effects. They can disrupt our satellites, GPS systems, power grids, and radio communications. That's why scientists at organizations like NASA and NOAA constantly monitor the sun, providing what we call space weather forecasts to help us prepare for these events. So, what's the future of our sun? Like all stars, it has a life cycle. The sun is currently about 4.6 billion years old, roughly middle-aged for a star of its type. It has enough hydrogen fuel in its core to keep shining for another 5 billion years or so, but eventually that fuel will run out. When that happens, the sun will begin to change dramatically. The core will contract and heat up, causing the outer layers to expand enormously. The sun will swell into a red giant, becoming so large that it will engulf Mercury, Venus, and possibly even Earth. Our planet would be vaporized. It's a dramatic end, but don't worry, it's not happening anytime soon. After its red giant phase, the sun will shed its outer layers, creating a beautiful glowing cloud of gas and dust called a planetary nebula. At the center of this nebula will be the sun's collapsed core, a superdense object called a white dwarf. This white dwarf will be about the size of Earth, but incredibly massive. It will no longer be generating energy through fusion, but it will be so hot that it will continue to glow for trillions of years, slowly fading into a cold, dark black dwarf. The sun is so much more than just a light in our sky. It's a dynamic nuclear furnace, a driver of space weather, and the anchor of our solar system. It governs our seasons, our climate, and the very existence of life on our planet. Every time you feel its warmth, you're re-feeling the energy from a process that started deep within its core hundreds of thousands of years ago. It's a constant reminder of our connection to the vast and incredible universe around us. From its fiery birth to its eventual quiet fade, the story of the sun is the story of our cosmic home. Thank you so much for joining me on this journey to the heart of our solar system. If you found this as fascinating as I do, make sure to hit that like button and subscribe for more adventures into the cosmos. Let me know in the comments what you find most amazing about the sun. See you in the next video.